Welcome to Creata classes. In this lecture, we will cover area of triangles. Let's take a triangle with sides as A, B and C, three sides. We have to calculate the area of this triangle. Let's begin. Let's duplicate the triangle. Means we have taken one more exact copy of this triangle. Both of these triangles are congruent to each other, that is, they are exactly matching each other. Let's join both the triangle with side C. Okay, both the triangles are exactly same triangles, so their side C will exactly match each other. Are you able to observe the figure? Both the triangles are forming a parallelogram. The opposite sides are equal to each other. So we can say area of this parallelogram is equal to area of the first triangle plus area of second triangle. And both of these triangles are exactly same, that is, both are having same area. So we can say area of parallelogram is equal to twice of area of triangle. That is, area of triangle is equal to half of area of parallelogram. And in the previous section, we have seen the area of parallelogram as base into height. If we take this side as a base and this perpendicular distance as height, we got area of triangle as half into base into height. Okay, this is the formula of area of a triangle. This is very famous formula. No need to mug up the formula, just you have to understand the fundamental. Formula will come automatically. Area of triangle is half the area of parallelogram, and we know area of parallelogram is base into height. So we got area of a triangle as half into base into height. This is the basic fundamental. Let's take different triangles and we will apply the formulas, so that your concept can be further strengthened. Let's take a normal triangle. Its area will be half into base into height. This side we have assumed as base. If we assume this side as base, then this perpendicular distance will be the height. Similarly, if we assume this as base, then this will be height. This is in similarity with the fundamental of height that we have covered in the parallelogram area case. Let's take a obtuse triangle. What will be the area of this triangle? Let's take this side as a base. Then what will be the height? This perpendicular distance will be the height of the triangle. Do not worry that this line is going out of the figure. We just need the height of the triangle. That will be the perpendicular distance from the opposite vertex. So for this triangle, area will be half into base into this height. Moving further, let's take a right angle triangle. Here, what will be the area of this triangle? If we take this side as a base of a triangle, then what will be the perpendicular distance, or what will be the height for this triangle? Here, if we take BC as a base, then AB will be the height of the triangle. The side itself will be the height of the triangle. So we got area of this triangle as half into base into height, that is half into BC into AB. Let's move further. Let's take a case of an equilateral triangle and we will try to find the area of this equilateral triangle. One thing that I want to point out is that the formula of the area of the equilateral triangle is very important. The same formula will be used in finding area of other figures also. Like in the case of regular hexagon. Okay, a regular hexagon is composed of many equilateral triangles. So the formula of area of this equilateral triangle will help you in finding the area of other figures and polygons. So let's proceed. Let's take a equilateral triangle ABC. Let's assume the side of this equilateral triangle as A. Being a equilateral triangle, all the sides will be equal to A. Further, from the vertex A, let's draw the altitude toward the side BC. Here AD will be perpendicular to BC, as AD is the altitude or height of this triangle. Here AD, that is this altitude of this triangle, is dividing this triangle into two equal parts. These two triangles are congruent, that is they are equal. Here if you observe, this angle is 90 degrees and both of the sides are equal to each other, and AD is the common side, so we can say both of these triangles are congruent to each other by RHS congruence rule. We are not going into the detail of congruency. Just you should know that both of these triangles are congruent to each other That is, the altitude AD is dividing this equilateral triangle into two equal parts. So by CPCT, can we say BD is equal to CD? Both of these will be equal to each other. The complete length of BC we have assumed as A. So we got BD and CD is equal to half of A, that is A by 2. Okay. Moving further, if we take the triangle ADC, ADC is a right angle triangle. So we can apply the Pythagoras in this triangle. Let's do so. Here AC is the hypotenuse. So we got AD square plus DC square is equal to AC square. Here AC it is A, and just now we have seen DC is half of A, that is A by 2. Let's put the value. On solving, we got AD as root 3 by 2A. Here AD is the height of this equilateral triangle. So we can say the formula of height of an equilateral triangle is A times root 3 by 2. Moving further, we are finding the area of this equilateral triangle. So area of the triangle is half into base into height. If we consider BC as a base, then AD will be the height of this triangle. Here BC is A and AD, that is height of this triangle, we have calculated as A root 3 upon 2. Let's put the value. On solving, we got the formula of area of the equilateral triangle as root 3 by 4 A square. Okay, this is the formula of area of equilateral triangle, and this is very important formula. This will be used widely over the geometry as well as in the segments of triangle as well as in the varieties of the questions. So you should know it. The area of the equilateral triangle is root 3 by 4 A square. Okay, got it? Let's move further. Our next topic is Heron's formula. This is one of the important formula. This formula is used when we know the three sides of the triangle. For that, let's take a triangle with three sides as A, B and C. The area of the triangle as per the Heron's formula is root S into S minus A into S minus B into S minus C. Here A, B and C are the three sides of this triangle, and S is the semi-perimeter of the triangle. We know the perimeter of a triangle is the sum of three sides of the triangle, that is A plus B plus C. We know A plus B plus C is the perimeter of the triangle, and semi-perimeter is the half of the perimeter, which will be equal to A plus B plus C upon 2. So S is the semi-perimeter and A, B and C are the three sides of this triangle. Okay, got it? In any case, if we know the three sides of any of the triangle, we can apply this Heron's formula to find the area of that triangle. Got it? This formula to be used when you are not able to find the height of the triangle. Otherwise, you can apply the formula, that is area of the triangle is equal to half into base into height. If under any circumstances you are not able to find the height of the triangle, then only you have to apply this formula. Because this formula is slightly complex in nature as it involves some complex calculations. So this formula to be only used when you are not able to find the area of the triangle through other means. So that's the Heron's formula. Moving further, now we will see the formula of area of the triangle when we know the two sides and the included angle. For explaining this, let's take a triangle ABC with the three sides as A, B and C. The three sides of this triangle are given as A, B and C, and one angle, that is angle B, is given as angle theta. We have to find the area of this triangle. The case is when we know the two sides and the included angle, that is the angle between the two sides. Here we are considering the two sides as A and B, and we are considering the angle theta, that is the angle between these two sides. When we know A, B and the included angle, that is theta, then we will use this formula or this case. Let's see what I am talking about. First of all, let's draw the perpendicular from the vertex A towards the opposite side, that is BC. Here AD is the height or the altitude for this triangle. Further, are you able to observe the triangle ABD? This triangle ABD is a right angle triangle. Here for this triangle ABD, let's find the value of sin theta.
We know sine theta is equal to perpendicular over hypotenuse. Here AD is the perpendicular and AB is the hypotenuse. Okay. So we got sine theta is equal to AD upon A. Let's find the value of AD. AD will be equal to A sine theta. Here AD, that is height of this triangle, we got as A sine theta. Let's find the area of the triangle, which we know is equal to half into base into height. If we consider BC, that is the side B, as the base for this triangle, then we got AD as the height of this triangle, that we have already calculated as A sine theta. Let's put the value. We got area of the triangle is equal to half into A into B into sine theta. This is the formula of area of the triangle, which includes the two sides and the included angle. Okay, got it. Here A and B are these two sides and theta is the included angle, that is the angle between both of these sides. If we take B and C as a side, then the formula will change to area of the triangle will be equal to half into B into C into sine C. Here angle C is this angle. Similarly, if we take side A and side C, then our formula will change to half into A into C into sine A. As per the side, the included angle will change. Okay, got it. These are the formulas. Okay students, we have done wide range of formulas of the area of the triangle. These are the list of formulas of the area of the triangle. These are very important formulas and you should know it. Many questions will be asked based on these formulas, and these formula will be used in other applications also, which includes physics and advanced mathematics. So you should know it. Okay?
I think your basic concept of area of triangle is fully cleared. So that's it for the area of the triangle. In the next lecture, we will cover the area of trapeziums.
So thank you very much for being with Creata classes. Bye for now.